By the end of this session, you'll be able to calculate and apply kinematic equations to situations involving gravity. We'll start by looking at a fairly straightforward question involving a falling object. An object is dropped from a height of 45 metres and we need to calculate the time taken to reach the ground and its maximum velocity. Now, we're going to take downwards as positive because we're using vectors, and in vectors, direction is important. So we're going to ignore air resistance and take g as 10 metres per second squared. So, as with all SUVAT equations, the first thing we do is write down SUVAT and fill in what we know. Now, t is what we want to find out to start with. We know it's fallen 45 metres. It starts from rest, so its initial velocity is 0 metres per second, and its acceleration is 10 metres per second squared. So now we need to choose a SUVAT equation that has those four quantities that we need to know in, and we're going to use s is ut plus a half at squared. If we substitute in the numbers that we have, then we find out that the time taken for the object to reach the ground is 3 seconds. We now know 4 out of 5 of the SUVAT quantities, so to work out the maximum velocity, i.e. the final velocity, then we could use any of the SUVAT equations. This time I'm going to use v squared is u squared plus 2as. If I substitute in what I know, then I find that the maximum velocity, the velocity the ball hits the ground with, is 30 metres per second. Have a go at this question.